Good morning. Excellent, we're on. Good morning, so happy to see you here all at Devoxx. We're gonna have a marvelous session here about GraalVM, how to run programs faster anywhere. And today with you, this is Thomas Wuerthinger, a researcher at Oracle Labs and the lead for the project GraalVM.
Thanks, Oleg. And yeah, so this is Oleg. He's a former Java champion and now the lead developer advocate for GraalVM. And yeah, we'll bring you through the session. We have a couple slides, but more importantly, we have a lot of demos, a lot of risky live demos. So we'll see how it goes. All right. So yeah, this is our safe harbor. And so let me introduce you to GraalVM. It's a new virtual machine. It is a new way how you can run programs. We published a release candidate a couple of months ago, and why would you care about GraalVM? So that's the first question. Like, why do you care about it? GraalVM actually has a lot of different things that it can do. Why do you care about GraalVM right now? So the first aspect is GraalVM is trying to run Java, Scala, Kotlin, and JVM-based languages faster. It does that via a new JIT compiler and a new way to compile such programs, in particular with less object allocations and with like faster peak performance. Second aspect is GraalVM has this mode where it can run these native applications also with instant startup, low footprint. You might have heard of projects like Scala native or Kotlin native and so on. So with GraalVM, you can actually compile all of the JVM-based languages like Java, Scala, and Kotlin to a native executable. And this can be interesting for microservices or other programs where like low footprint, low memory footprint, and fast startup is important. And finally, GraalVM has also this polyglot and embeddability aspects where it can run not just those languages that are here on the slide, it can also run JavaScript, Python, Ruby, R, and LLVM-based languages. So these are the three things that GraalVM can do at the moment, and that's why you should care about GraalVM. This picture illustrates the whole ecosystem a little bit, where GraalVM is a language execution platform, and on top you have JVM-based languages on the left, and then the various dynamic languages that GraalVM can also support, and on the right you have the LLVM-based languages. And GraalVM has this special way of transforming interpreters of those languages into efficient compiled code. But one of the things maybe a little less known about GraalVM is that it not only supports multiple languages, it also is embedded in multiple platforms. The usual embedding of GraalVM would be here in the OpenJDK platform. In this setup, we are executing JVM-based languages in the context of the Java Hotspot virtual machine, which is the standard virtual machine that comes with the OpenJDK. In this setup also we support all of Java, like you can run any Java application. So if you have an existing Java application that runs with OpenJDK, it's going to run with GraalVM in this specific embedding. But with GraalVM we try to be a little bit more runtime agnostic because we want to also run in other settings. One of the settings you can run in is Node.js, where we run in a normal Node.js process. So Node.js controls the event queue, but you then can still run GraalVM-based languages in the context of Node.js. So you can, for example, run Java, you can run Ruby or R in the context of your Node.js application. Well, we are from Oracle, so we also had to embed it in the Oracle database. So there, like you can run it as well as part of your query execution or as part of your user-defined functions. We have a prototype in the MySQL database, and in general, we actually see more data processing engines to potentially embed Graal. Just because Graal allows you to bring kind of your program closer to your data, so you can have logic executed, filtering your data before it is sent over the network to another node. So this enables, for example, uses like Python machine learning inside the database, or also JavaScript use cases inside the database. And finally, GraalVM has this standalone mode, standalone or native image. We call it GraalVM native image, where GraalVM executes completely standalone without any environment around it. And it's just a managed application with a garbage collector and nothing else. And this is what gives us the better footprint and faster startup in certain scenarios. I'd like to go a little bit more into detail into how this standalone deployment is done. So the way we do this is that we take a Java program, a Java application, and what we do is we do a static analysis from the starting point of the Java application, from the main method, and we figure out every code path that is reachable from the main method. Because one of the issues with static compilation in Java is that if you compile the whole JDK into your final executable will be too big. So we want to figure out exactly what parts of the JDK is your application using, and then only compile those parts into the executable. So we do this with some closed world analysis, where we basically figure out the boundaries of what is reachable. And then this allows us to provide then efficient machine code from this specific program. We then compile this down into a machine code. There's also an image heap involved, in the sense that you can actually prepare a certain heap that is immediately available at startup of your application. It's a little bit of like a snapshotting mechanism. Because one of the problems with startup time in Java application is often that static initializers have to be run in the interpreter, and like they create some data. And if you can grade this data before during image generation time, then your Java application is going to start much faster. So yeah, so native images of GraalVM is this full EOT compilation to machine code. It is still a secure execution with bounce checks, so not like C code where you could have buffer overflows or similar, but it is fully native code in the end, and it is a native executable or native object files that can be linked with other native code. So this native image generation has some limitations at the moment, so we cannot support any Java application because we need to do this closed world analysis, and it doesn't work on any Java application. But we're actually like currently collaborating with a couple microservice frameworks, also including Spring Boot, in order to get support for more and more applications, in particular in the Java serverless space. And one thing to remember here is like this native images is just one way how to run GraalVM. We can also run GraalVM in the OpenJDK setup, and in that setup we support all Java programs. So if you find on Twitter somebody saying, I don't know, GraalVM doesn't support reflection or something, that's not true.
Call them out.
Exactly.
Tell them it's not true.
It's not true. GraalVM supports everything. It's just that if you go back to this setup here, that in the standalone configuration, we do not support some constructs at the moment that we're working to resolve. But in the OpenJDK configuration, we support any Java program. So Graal is an open source project. It's on GitHub. You find on GitHub here this is the main repository. There are additional repositories on GitHub where we have the language implementations for JavaScript, Ruby, Python, all open source on GitHub. So it's a couple million lines of code that we maintain in the project on GitHub. And so GraalVM has 2 editions. It has the community edition, which is built from the bits that are out on GitHub, and it's free to use, also in production. And we have the enterprise edition, where we have additional performance and security optimizations. And for the enterprise edition, there is a requirement to take a license. We are kind of upfront about this, that we have an open source part and a closed source part in our project. So this is like our strategy and how we would like to make the project successful.
All right.
All right. So with that, I give it over to Oleg, who will start with the first.
That was the introduction, right? Hopefully you are very excited. There are a number of points why one would like to use Graal in production. And Thomas, I have a question to you. So you said it's a faster way to run Java workloads, right? Scala. What do you mean by faster? Faster than what? There are so many different things called Java nowadays.
Right. Yeah. There's a lot of OpenJDK distribution nowadays, but most of them are just different builds. So we actually replace the compiler, and by faster I mean faster peak performance. So not necessarily faster startup. So in startup, actually, when we run on hotspot, we are a little bit slower. But for peak performance, Graal provides a very good result.
Excellent. Well, let's see if we can do that. I've heard that Graal compiler is a part of the recent distributions of the OpenJDK.
That's true. The Graal Community Edition is in JDK 11.
Excellent. We're going to try that. So yesterday I caught a glimpse of a benchmark that multiplies complex numbers. So imagine we have a class like this. Complex number, imaginary part, real part, it has a multiplication method that is immutable. Immutable data structures are good. And we have a benchmark that just populates a matrix of complex numbers and then just multiplies those, right? So essentially a 3 layers deep loop that does some things. And then we're going to run this benchmark, and I'm going to run it first on Java 11 -- version. You can see it's a normal Java 11 release, and I'm going to run it with Java -jar targets benchmarks, right? So it's gonna start. The benchmark is written using the Java micro benchmark harness, so it kind of helps us not to commit the most obvious mistakes while benchmarking things, right? You have to understand that this is still like just data, right? The numbers that it will show us, we need to interpret them and we need to understand them, but it gives us hope that it's not completely broken. Actually, it's a decent benchmark. It's a good benchmark. So this particular machine is not like a server-side hardware, but it shows us. So what we have here is that to run this multiply method with Java 11, we spend 7,700 of units of time per operation. And now I'm going to enable Graal compiler, which is a part of the OpenJDK distribution. And this is what you can do if you use Java 10 or 11. And I'm going to have this, this command. I need a couple of command line options. So I have unlock, experimental VM options. And then I have the $X plus use JVM CI compiler. So the JVM CI compiler, JVM CI is the Java Virtual Machine Compiler interface, right? This is a normal way how you plug your third-party compiler into the JVM. It was added as a part of the JEP during Java 9, so a couple of years ago. For our builds, we backported to Java 8, so that's how you can get the GraalVM distributions based on Java 8. But in normal Java distributions, it's a version of Graal compiler, the open source one, is included. It's not exactly the master that we currently have on GitHub, but it's a snapshot that was available at some point of time, in the recent past, right? So they're actively pulling them, the Graal compiler sources to the OpenJDK forest, and they run it, and we have the result. And previously we had 7,700 of units of time, and now we have 35. So that shows that on this benchmark, the community edition, the open source edition of the Graal compiler achieves something like 2x, a little bit more than 2x performance speedup. This is one, like, if this doesn't convince you that you should at least evaluate and try it, then I'm not convinced that you are very performance aware.
But to set expectations, like, this is just one benchmark, so your mileage may vary, right? But it's an interesting benchmark. It's one of the benchmarks from the Valhalla project, and I just want to tell a little bit on why we are faster here. So the reason why we are faster here that Graal is good at removing high-level abstractions. In this specific case, object allocations. So we got this loop of complex numbers here where we use a complex number object abstraction, and Graal is able to remove all of the allocations in that loop. So if you actually test the allocation rate here, the allocation rate goes down substantially with Graal. But so generally, if you have a complex type of program, it's definitely worth trying Graal. In particular, if there's a lot of object allocations and method invocations. So this is where Graal, even the community edition, gives benefits. And specifically true is that for Scala code, so we get a lot of reports for Scala programs where they do run faster. But yeah, so Graal not only has the community edition, it also has the enterprise edition, and maybe show one performance aspect that the enterprise edition can do very well, Oleg.
Yeah, if you are interested in additional performance, in this additional performance boost that the enterprise edition compiler can give you, that's reasonable. It really shines on high-level abstract Java code. So as Thomas said, other JVM languages, which maybe do not produce the patterns of bytecode that are so known and so similar to the Java bytecode patterns, right? And the performance boost is there more pronounced. And it also comes with a really good heuristics for inlining and polymorphic inlining. So we are doing really well on the code that has small methods and maybe chain methods. And maybe if you've seen an example of a stream, of a code using Stream API, this is exactly what Graal compiler can optimize really, really well.
Right, show us, Oleg.
Let me show you. I have the code here. Let me make it a little bit larger. It's a small benchmark. We have an array of numbers, and then we stream them, and then we map a couple of operations until we reduce everything to a sum. This looks like a Java 8 code, and this is a Java 8 code. And I'm going to run this using the GraalVM distribution. So if we check this out, so I will just show you not a benchmark, but I will show you ls bin. If you download the GraalVM distribution and you unpack that, right, you get a distribution that is very similar to normal Java distribution, right? You have all your normal Java commands, Java, Java-C, Java-P, and so on. So you can unpack that, and you can just change your Java home to pointer and add that Java to the path. And this is a drop-in replacement for normal or any other Java 8 distribution that you're using, right? So we're going to use this Java, and we're going to use it and run it on this benchmark. First, I will run it without Graal. So I would run it with normal C2 compiler running. To do so, because I'm going to be using the Java utility from the GraalVM distribution, which has the Graal compiler enabled by default, I will disable that. I will pass this flag not to use the JVM compiler, and then it will not use Graal compiler, right? So, and I want just to do that to give you a point of reference to see if using the Enterprise Edition Graal compiler can speed up this benchmark. So it's going to take us half a minute more, but it's also the JMH benchmark. It warms up, it runs a couple of iterations, all the previous conditions and disclaimers about running benchmarks on a not the most powerful MacBook running several Docker containers and an additional very large monitor. Apply.
Right, but the result, I think,
yes,
will be significant enough to.
We'll see. So you can see that currently, for a single invocation of this test method, we spent 175 nanoseconds, right? So one iteration of this code takes that much time, and I'm going to run it with Graal. So just the run sh, right? I do not disable Graal, and it will run by default with the Graal compiler. And I'm not going to show you the score first, because it will still take 40 seconds. But we'll stare at the code, and we'll vote a little bit. So who thinks it will be faster than... OK. Who thinks it will be slower or on par with normal? That's right. I wouldn't show you a demo where it's slower. That's correct. So the question now is, how much faster can it be? So who thinks it will be like 2-3% faster? or more. 2%, it's not that much. Yes, JVM is a state-of-the-art virtual machine. It's performance tuned for 20 years. It's a great technology, but who thinks it will be 5% faster or more? Reasonable? 10% faster? 50% faster? Still have people voting? 2 times faster. We have optimists in the audience tonight. 4 times faster? 8 times faster? I mean, this grows out of hand pretty significantly.
Yeah. Let's just show.
Let's show it. Let's see how much faster it is.
What's
so,
gonna happen?
One invocation of this method takes 10 nanoseconds. Previously, we had 180. Now we have 10. That is 18 times faster.
Right.
Thank you. And that is...
Right, yes, but as usual, the disclaimer, it's just a benchmark. Your mileage may vary. But in this specific one, what's interesting, if you can go to the code a little bit, is that this is, like, if you have looked a little bit into the insides of the Stream API implementation, this is a lot of code that, like, Graal needs to actually compile inline, unroll loops. It's pretty decent. So the number of constructs Graal needs to deal with to reduce that is quite a bit, because we do not have like this special case if Stream API do something, but we really truly just read the bytecodes of the Stream API and optimize them. Which means if you use another type of framework like Spark or something else, it can also take advantage of that. And in this specific example, it's actually a combination of escape analysis, loop unrolling, and inlining that reduces that whole expression then to the final just for loop that does the work. So it can fold this like automatically. So if you care about Stream API performance, like Graal Enterprise Edition is definitely something you should test on. All right, cool. That was on peak performance, Oleg. Let's switch it over.
Yeah, let's see if we can make our Java program snappier. I think to the left.
I hope I shouldn't press the wrong button, no?
Ta-da! Did you press something as well?
No. It looks okay.
Can we... can you press back? Maybe mine will work.
I think it will... It's now. It's on.
Yeah, this is mine now.
This is just... Okay.
This is not a part of the rehearsed demo. They show us 2 buttons, but being software people, hardware probably is not our strongest thingy.
Yeah,
let's switch the cables.
Yes, let's switch the cables. That should work fine. Yeah, it's
Ta-da! Yeah, it's gonna work. Excellent.
It's sort of working. Not exactly the resolution I was looking for. All right. Better. Excellent. All right. So I will show you a little bit on the fast startup side of things, a little demo. And so for this, I will show you here a Java command line tool. It's a Java application that is just here. It's a little command line tool that goes over files and lists files. It's like the LS version of Java. Really not much code. And when I can do it here is I can select Java list dir, which is gonna list the directories. But it's kind of okay, but it's not super snappy. If I actually time this here, it's about 200 milliseconds in startup for just an application that goes over files. And so what I can do in order to make this better, I can now use like the GraalVM native image tool. And so in the GraalVM binary directory, as Oleg showed, you got like Java and all of these other commands. You also have a command that's called -native image. And I can give it here the entry point to my command line tool, which is called list dir. And it will now start an ahead-of-time compilation process, where it will look what is reachable from my main of my Java application. It will do like an analysis of that. It will prepare a snapshot of the heap that will end up in the final executable. And it will then compile everything that it found, do some inlining, and in the end, write it out to disk. All right, so we got now here a list.dir executable. It's here 7 megabytes. It's not super small, but we like when you use some Java stuff, you immediately throw in a lot from the JDK. But still, for example, you could now use the 7 megabytes, create a Docker container on a very lean image, and this will deploy this stuff. If I now do the list.dir, this is now an executable that I can just call, and it does the same thing. If I now actually time this, it's 13 milliseconds. Just for reference, the original one was, yeah, about 190. It's about 10x better startup. So that's cool, but I don't if well if I'm actually using, for example, Java-C here, and I'm compiling with Java-C this list.dir class. Let me just show you here the command line I'm using to compile this list.dir class. So if I compile this class, if I'm using Java-C here, yeah, it takes like 500 milliseconds to compile, right? I mean, it's just one file. It shouldn't actually take so long, right? So what I actually did before, I created a native image for Java-C, which you can see here. And I can now actually use the same command line. So let me just show you also the size of the native image for Java-C. It's a little bit bigger, but actually not much. It's just 16 megabytes here. And what I can do is that was pretty fast. Let's just time that a little bit. It's 50 milliseconds. Again, a 10x in startup. And to actually demonstrate you that I'm not cheating here, that it actually did something. All right, it's not here. It's here, all right.
1, 2. This is a good example that you can compile non-trivial programs to a native image, right? But I haven't heard many people complain about the snappiness of Java-C. Can it work on Scala compiler? I've heard those people kind of have a larger problem with compilation times.
That's actually true, and we have. So and for Scala compiler, like Graal compiles about 35% faster. Also for longer running processes, because for Scala, the issue is sometimes compile times of 10 minutes, 20 minutes. And so then, yeah, we take off a few minutes of that compilation time. And so this startup thing is nice for command line tools, but it's also nice for Java serverless frameworks. And so I was listening to a talk a couple of days ago on Micronaut, which is one of these Java frameworks. And so I was following the Micronaut demo, and I was very excited because Micronaut has already support for GraalVM native images, some experimental support, where you can create a Micronaut template with GraalVM native images. And I have here a little Micronaut Hello World application, and I can start it here with Java. And it starts off in about a second here. It has a server running at this place, and it can basically get requests after 1 second, right? And what I did again is I created this native image. This one is this here. It has about 48 megabytes, which actually, I mean, it sounds big, but if you, the Docker container with that native image is going to be smaller as well than the full program. And I can start Micronaut now with this server, and the server started in 19 milliseconds. So before it was like about a second, now it's 19 milliseconds until the server can get the first request. It's not just that, let's just look at the activity monitor here, and let's look at the memory consumption, it's a little bit small to read. Yes, it's 19 megabytes here. It's 19 megabytes memory consumption here for this micronode running the server. And if I'm starting the server on the normal JVM, it's this one here. It has 135 megabytes, or 110 megabytes in this case. So you also get like here, like a little factor in terms of memory consumption, which might be relevant if you want to fit more microservices on one computer. And generally, memory is one of the most expensive things in the cloud. So that's on Java startups, startup demos. And yeah, so we're still not there to run any applications, and we're still working with Micronaut and Spring Foo and other frameworks to get them running. Still, we already appreciate feedback for native image. So if you have an application where you care about startup, you can try it and give us feedback whether you can do a native image on it, and yeah, or just give us feedback on what limitations are currently preventing you from doing a native image.
Is anyone doing cloud, like function as a service platforms, like using them? Well, I've heard startup is very important there. So hopefully you'll have a chance to look at what GraalVM can offer you.
All right, so let's go to the next one here, because we have like a little more demos prepared. So one demo I want to show you here is the Polyglot Demo, which is also one interesting thing you can do with Graal. It is, I have here a little program, and that program is a normal Node.js application. It's using Node.js here. From Node.js, it's using Java, here Java big integer, to compute something. And then it's using R, the statistical language R, to compute something here, and then to actually draw. It's using R inline to draw a little diagram. And what I can do is I can now, again, use GraalVM here. And in the GraalVM bin directory, you might have not noticed this before, but there's not just a Java command, there's also a node command. So we're going to use the node command here, which is going to run Node.js. We'll have to give it two flags in this scenario because we need to run on the JVM. You can run the node either standalone or on JVM with GraalVM. We need to run it polyglot because we want to include also support for R, because we are calling out to R. And then I can run my server here, which is going to start up on the JVM in this case. So it's going to take a little bit.
But it's going to be a normal node, right?
Pardon?
There will be an event loop, and it is.
There is an event loop. It's normal Node, and it's fully compatible with Node. So, actually, that's kind of that's not an error because Oleg, why is that not working?
Yes, so I can show you this demo on my machine maybe quickly. Maybe later.
No,
maybe later.
But why it's not working?
It's not working because when you download the GraalVM distribution, one of those, either Community or Enterprise Edition, there are a number of components that are built in, packaged in. That is Java, that is Node, that is JavaScript, that is the LLVM bitcode interpreter, and a number of components for other languages, support for other languages is not packaged in. There are a number of reasons of that. The largest is that the compatibility with the ecosystem for those is a little bit less 100% as we have with Java and JavaScript. So they are distributed as standalone archives. So what you need to do, you need to install that into your GraalVM. You do that by using the Graal updater utility. So there is a GU thing in the distribution, and you can list, install, and uninstall components for the supported languages. So if you run GU list, it will list the available components. So that would be R, Ruby, and Python. Yes. And the distribution for those are just the interpreters for the languages are open sourced. They sit on GitHub. The releases get uploaded to the GitHub as well. And the GU downloads that, and then it just runs, places the files into correct places. So what you need to do,
yes,
if you...
So what I did is basically I said, I was missing the R installation because I was installing from scratch. And so I did GU install R, and that basically pulled me the R language from the servers. Because we think of GraalVM as an open ecosystem. Other people might add additional languages. So we already have a plugin architecture with languages. The standard distribution comes with Java and JavaScript support. So after that, we have here now our web request. I can call this multiple times, and I'll get here like the hello world from JavaScript. Here is the big integer calculation with Java, and then I get here the plotting from R. So this can be interesting when you, for example, want to use R or Python to plot something, but you have a Java application or a Node application, and you can here with GraalVM mix those two things to get to benefit from the library of a specific other language. So in addition to all this R, Ruby, and JavaScript and all these things that you can run, we can run also LLVM bitcode. And one specialty we have is that we can run the LLVM bitcode sandboxed, so with bounce checks. Because our compiler is very good at removing bounce checks because it is doing that for Java all the time. And so we figured that like maybe we also want to run C bounce checked. And so the little demo that I have here for this specific aspect is on sandboxed native gzip. So I have here a gzip program. It's a reasonable like sized native program. And we modified that gzip program a little bit to make a small mistake that often happens in C. So I'm here allocating an array with size 10, and then I'm like assigning that. And in C, that can be a security problem actually if you do that, because with buffer overflows you get access to wrong data and so on. So if I'm now, what I can do here is I can run this gzip. Like one of the things in this GraalVM distribution is an executable called LLI, which runs LLVM bitcode with the Graal compiler, and I can use this here to run, for example, here a gzip on this small file, and it now basically created the small file gzip. And because I have this modified gzip, if file name is too large, then gzip is gonna crash. So I have here like a traditionally compiled C file with this bug in it, and if I run it, I actually get a trap. I get a trap 6 and a crash. This might actually be sort of okay for me, but not ideal. But worse is actually if the attacker can get, for example, a secret and I don't even notice it, which can also happen, right? And so what I can do now with GraalVM is to execute sandboxed, and I'm executing again, and I'm using the file name is too large. And what I get is like what Java programmers are very familiar with, an out of bounds access. And it tells me like in which part of the C file that is, and so on and so forth. So we can here sandbox C code, native code. We can make sure it cannot like attack you, the C code, like it cannot like access things from the system, and we can make sure it cannot crash a Java application, for example. Because sometimes even if you, for example, compile Java and C code, if with GNI, if your C code is corrupting the heap, your Java application might crash. Right, that's just one other small thing we can do there with Graal. And let's just go now to the final demo here, which is the database integration. Because Graal, as I said, can run on the JVM, it can run in Node.js, it can run standalone, it can also run in the database. So for this, I have on my little laptop an Oracle database instance running in a Docker container. And what I have here is I have a table of tweets. I can just, I'm now putting on my database developer hat. And yeah, so I'm just getting a few tweets here, and I can also select count. Let's see how many tweets we have. We have about 1.6 million tweets in the table. And what I would like to do is a sentiment analysis of the tweet. And I found like on npm, on the Node repository, I found like this little library. It's called Sentiment that does sentiment analysis for Node.js. It basically can analyze a sentence in certain languages, and it gives you a score whether the sentence is positive or negative.
So normally I would write that in PL SQL, right?
Right. Yeah, if you have a lot of time and you wanna write it from scratch, and also maybe maybe there is a pre-existing functionality, but maybe you want a little bit different and you want to customize it, and then you can use like one of these packages.
Excellent. Who here knows how to write text sentiment analysis in PL SQL?
Oh, nobody. Okay.
Who knows how to install a JavaScript module?
Excellent. Perfect. And that's so we kind of what I did here, just to show you a little bit of the code on the MLE. It's called Oracle MLE, this specific part of the project. So I'm using this sentiment. I'm using this sentiment library here, and I have this little send function where I'm analyzing the sentiment and I'm giving back the score. And so let's just select. Now let's just describe the table again, describe tweets. And what I can do now, basically, I can use this JavaScript function as part of my query, like any other function. And so I can now select send of content and the content from tweets. And then we want to order by S. We want to ascending or descending?
Descending. We want good tweets
are you sure,
on
Oleg?
the top.
Who wants to order ascending?
Good tweets on the top.
All right, excellent. It's a good audience. It's a good audience. So we ordered descending.
Excellent. Thank you.
All right, so this is now going over 1.6 million tweets, so it takes a couple of seconds. But remember, for each of those tweets, we are invoking the whole sentiment analysis written in JavaScript and execute that with GraalVM in the Oracle database. All right, okay, it was a good decision to order descending. So this is the top 3 tweets in our tweet set now with that sentiment analysis.
Yeah. So we saw in previous benchmarks that Graal was really good as a JIT compiler, right, to optimizing stuff at runtime. If you run this again, will it be faster?
It will be a little bit faster, but like we are optimizing already during the first run because we are running over 1.6 million tweets. So yeah, but generally, if you like in this specific case, we would, for example, cache the machine code, and we would run better on the second iteration. All right, cool. We have 7 minutes left, so we go back to the slides and
yeah, excellent. This is power.
This is power. All right. Maybe you need that as well.
I have mine. Yeah. So we showed you a couple of demos. There are more things that you can do with GraalVM. And I'm sure we have a blog, a team blog, where we publish articles where you can find them and you can experiment with different things that we show there. And it's a very versatile platform that has many very exciting capabilities. So what we talked about currently, first, we talked about high performance, but that is self-explanatory.
Yes.
Then we talked about low startup.
Yes, and so this is here Netty startup. So this is just a Netty web server measured in startup and memory size. We are ECMAScript compatible.
Yes. 2016, 2017 with few features of 2018 standard.
Yes.
This is the level of compatibility of Node and browsers.
Yes. So if you run JavaScript on the JVM with GraalJS, you get the latest JavaScript, and it's competitive with browser engines. Like you see GraalVM here on the right. Are we fast on JavaScript?
Yeah, we are decently fast. Remember, we talk about peak performance, and this is what the JIT compiler is really great at. So we run a number of benchmarks compared to other JavaScript implementations on the JVM. And you can see this particular table is normalized to Nacron results. On the composite score on the very right of you, the community edition of GraalVM is around 4 times faster. The Enterprise Edition gives you this additional boost if you choose to receive that.
Right. So this is another
faster.
instance where Community Edition is already very fast. So it's not like the Community Edition's performance is going to be really bad. Also, the startup thing is also there in the Community Edition. It's just that Enterprise Edition gives you a small additional boost. Right, so this is Ruby performance. We need to skip a little bit because we don't have so much time left. We can debug in the Chrome debugger, Chrome browser. All languages, actually. We are debugging Ruby, R, Python in the Chrome browser. We have Visual VM.
A heap viewer. If you want to figure out where does the memory go in your JavaScript application, you can use that using tools that you know and love.
But the Visual VM is only for Java, right?
Well, there is a version of Visual VM embedded, included in the GraalVM distribution, and that is GraalVM language aware. So it will show you things for JavaScript, Ruby, Python.
Yes,
and
so other languages.
And other languages. Everything that we support.
Cool. Python support. So Python is not yet there to the same level of compatibility like R, Ruby, or JavaScript. We're actively working on that. We started with Python, I think, about half a year ago. It will still take us a little bit, but we are fully committed to support Python with NumPy and SciPy. Windows support, almost there. Many people have asked us for that. We will put Windows support for all editions out there. And generally, like we didn't have, I think, Mac support for the Community Edition, and then everybody was like, oh, like, are they holding something back on a certain platform? We're not going to do that. We are going to move, like, all of the platforms are going to be available on all editions, Community Edition and Enterprise Edition.
So if you're currently interested in the Windows builds, and there is a preview that includes a Graal compiler that you can use as a JIT for your JVM languages, but not the other components. So you can download that from the Oracle Technology Network as well, and try that if you are mostly interested in improving peak performance of your Java applications.
Yes, we have the Windows build already up there, but it's still not as the default distribution. Right, am I gonna use GraalVM in production? Well, it's a pre-release thing at the moment. It's a release candidate out there. There are some bleeding edge companies like Twitter using it in production right now. You might have seen a talk by Wuerthinger how they use Graal to speed up their tweet servers. So there is already some using in production, but yeah, it's only for bleeding edge people at the moment. We look forward to feedback from you guys. It's very important for a project like GraalVM to get feedback, to get ideas on where we would apply some of the technology we've built. And so for this, we encourage people to really try it out. Tell us like what you like. Tell us which language you would really like to get supported, and discuss with us on GitHub or Slack or Gitter channels. That's really helpful for our project if we get such external feedback. And we're very thankful for the feedback we already got from the Clojure community, for example, and other guys who have helped us actually push this project forward since we put out publicly 6 months ago. Because building Universal VM is a community effort.
Yeah, we can only run so much code ourselves. We can only find so much bugs ourselves. The code is out there on GitHub. It's an open source project. We are open to communication. We would love you to try it on your sample workloads, actual workloads, performance tests. Come back to us with feedback. The team is committed to make it the fastest default runtime for the languages. So
yes,
in the future, for any language. And you should be able to run it faster anywhere.
Exactly. Thanks for your attention. And yeah, please vote for us on the speakers app. And but more importantly, actually, give us feedback on GitHub, Twitter. Direct message on Twitter as well is open. We really appreciate if somebody in the real world is testing that stuff and telling us like, you know, because we are like Oracle Labs researchers, so we are like come a little bit more from the theoretical side. So it's very important for us in the current phase of the project to now understand how in the real world, like in a practice environment, this technology can make a difference. And for this, we are dependent actually on feedback from outside. And I think that's the most important message I think to take home from this talk today is like, if you're interested, if you find this technology promising, please try it out, give us feedback, and tell us where we should bring it further.
Thank you.
With that, thank you for your attention, and thanks for coming.